Okay, so you guys have done matrix multiplication now by hand and on the calculator. You also asked about matrix division. There is no matrix division, but what we do, in case we need to do some sort of quote-unquote division, we multiply by the multiplicative inverse, or the inverse of a matrix. Okay, it'd be like if you wanted to divide both sides of the equal sign by 3, you could instead multiply both sides of the equal sign by its multiplicative inverse, or 1/3. Okay? So that's essentially what we need to do with matrices, is if you need to divide matrices, you actually multiply by the inverse of a matrix instead. Okay, do you guys understand that concept? How it's the same as numbers. So instead of dividing matrices, we multiply by its inverse. Okay, which is not its reciprocal, it's different. There's a different way to figure out the inverse of a matrix. Okay? First of all, I guess I will show you a proof. You don't need to know this proof. Okay. Before I get into the details of this, if you take a number, 3, and you multiply it by its multiplicative inverse, 1/3, what do you get?
1.
7 times 1/7. 2/3 times 3/2. So if you multiply a number by its inverse, multiplicative inverse, you always get the number 1, right? Okay? Matrices are the same. If you take a matrix, so in this case here we have matrix A, and we multiply it by A inverse, its multiplicative inverse, we don't get the number 1, but remember how we've talked about the identity matrix being just like the number 1 as far as matrices are concerned? Okay? That will always happen. If you take a matrix and you multiply it by its inverse, you will always get the identity matrix, which is like the number 1. Okay, does that concept make sense? Questions? I'm trying to relate it to numbers, because I think everybody can understand 5 times 1/5, 1. 2/3 times 3/2, 1. When you multiply two multiplicative inverses together, you get the number 1. Okay? And that's essentially, we're going to be working with multiplicative inverses as far as matrices are concerned. So, how do you find the inverse of a matrix? How do you find the multiplicative inverse of a matrix? Unfortunately, you can't just reciprocal all of the numbers inside it. It's not that simple. Okay? So, let's say we have some matrix A. Alright? Let's say we have some matrix A. The inverse of that matrix is this right here as follows. Okay? And let me kind of explain what happens here. Now, how they figured that out, I'm not exactly sure myself. Okay? Might have been through lots of trial and error. But, to find the inverse, does everybody understand this A to the negative 1 power? That's another way of saying A inverse. We've done F inverse of X before, you know, in Algebra 2 and probably here. Alright, F to the negative 1 of X, F inverse of X. Alright? So this A to the negative 1 power, that is referring to the inverse of matrix A. If you want to find the inverse of a 2 by 2 matrix, here's what you do. The first thing you do is you find the determinant. Okay?
Should we write that part down?
I would write this part down right here. You don't need to go through the whole proof of it though. Okay? But so let's say you have some matrix A, and let's say the elements inside of it are A, B, C, D. Alright? So let's start by writing that down. Matrix A is equal to A, B, C, D. So we're just going to do a 2 by 2 matrix here. Okay? If you want to find the inverse of matrix A, the first thing you do is you find what's called the determinant. Okay? And the determinant is found by taking the product of A times D and subtracting the product of this diagonal, B times C. Alright? So again, you're going to take A times D, multiply those two numbers together, minus B times C. Multiply those two numbers together. That'll give you your determinant. Alright? Then, you'll take 1 over that determinant, 1 over that number, okay? And you'll multiply it by this matrix right here. Now notice, not much changes, just a couple things. The D and the A, they just trade spots. And the B and the C, they just change signs. They become opposites of whatever they were. Okay? So if I had some matrix B right here, if I wanted to find the inverse of matrix B, I would first find my determinant. So 3 times 1 is 3, 2 times 4 is 8, 3 minus 8 is negative 5, right? Everybody follow me?
Can you repeat that one?
3 times 1, I take A times D minus B times C. So I multiply A and D together. 3 times 1 is 3. Okay? 3 times 1 minus 2 times 4. Okay? So I take AD minus BC. So 3 minus 8. Good? Okay? So I have 1 over negative 5. Alright? And then D and A, they switch spots. So it was 3, 1 this way, so now I'll put the 1 here and the 3 down here. So the D and the A value, they switch spots. And the B and the C value, they just switch signs. So negative 4, negative 2. And then I would just go ahead and multiply that negative 1/5 into every number there, just like you would with any scalar multiple. So negative 1/5 times 1 would be negative 1/5. Negative 1/5 times negative 4 would be positive 4/5. Negative 1/5 times negative 2 would be positive 2/5. Negative 1/5 times 3 would be negative 3/5. And there is your inverse matrix of matrix B. And if you were to multiply matrix B and this one together, if you were to multiply these two matrices together, no matter which way you do it, okay, this is the one time where it will work either way, alright, if you were to multiply these two matrices together, you would definitely get your identity matrix. It's like getting the number 1. When you take 7 times 1/7, you get 1. When you take 3/4 times 4/3, you get 1. Okay? So these are inverse matrices of each other. If you were to multiply them together, and that's how you would prove it. If I would say this, if I would say, prove that this matrix and this matrix, prove to me they are inverses of each other. Well, if you want to prove to me that two matrices are inverses of each other, just multiply them together. What should you get? The identity matrix. Okay? 1, 0, 0, 1. Alright? So it's a little bit of a process. You do have to memorize it. Okay? You do have to memorize how to do this, how to find the inverse. Okay? I don't know if I have much to help you with. Obviously, you just need to memorize how to find your determinant, AD minus BC. And then honestly, what's stuck with me forever, the A and the D, they switch spots. The B and the C, they switch signs. So this diagonal switches spots. This diagonal switches signs. What I've always remembered, I don't know why, okay? But, you know, when you used to do your assignments, when I used to do my assignments when I was in high school, the teacher always asked me to write or sign my name right up here in this corner, along with the assignment. I always put my signature or my sign right up here. So that's the diagonal. That changes signs. I just remember that's the one. I don't know, it's worked for me. It's always stuck. Okay, as corny as it is. But That's what some people forget. They forget which one switches spots and which ones change signs. So I remember top right corner, that's where you sign. So that's the diagonal that switches signs. So, okay? So anyway, that's how you find inverse matrices. Okay, the inverse of a 2 by 2. All this is right here, guys, is this is a proof. Okay? This is a proof.
So that last matrix was your answer, right?
Okay, that was B inverse. Yep, that one was B inverse, whatever that one was. Okay, all this is right here is this is a proof. Okay, showing you how it works no matter what values of A, B, C, and D are. Unless the determinant equals 0, why would that be impossible to do then? Can't divide by 0, be undefined. Okay. Alright, obviously if A times D minus B times C equals 0, that matrix does not have an inverse. Okay? Because you can't do its determinant then. But all this is just a proof.
How can you not have an inverse?
Okay? 0 doesn't have an inverse. Like the number 0.
Yeah.
Because you can't divide by 0. So,
That'd be the only situation.
that's the only number that doesn't have an inverse, but there can definitely be different matrices that don't have an inverse. It just means it's impossible for it to multiply together with something that would equal the identity. I try to explain how matrices are like numbers, but they're not exactly like numbers, but there are some similarities. Okay. So that is, this right here is what you want. I guess I can put that up. Again, if you want, okay? So, matrix A is this. A inverse is 1 over AD minus BC times A and D switch spots, B and C switch signs. So there's how you find the inverse of a 2 by 2 matrix.
So, and the A times D minus B times C is your determinant.
This is called, yep, this value right here is called your determinant. Okay? And as long as the determinant doesn't equal 0, you can find the inverse of any 2 by 2 matrix. As long as the determinant doesn't equal 0, you can find the inverse of a 2 by 2 matrix. Because you can't divide by 0. Jenny?
Well, we have any bigger.
Great question. So this is a 2 by 2. Finding the inverse of a 2 by 2 matrix, you guys definitely know there are other matrices, okay, other than a 2 by 2. First of all, you can only find inverse matrices of square matrices. So it's got to be a 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, and so on. Anything else you're asked to find the inverse of, you'll use your calculator. Okay? If you look on your matrix button, the button that you actually use to get to the matrix screen, you see how the button itself says x to the negative 1 power? Okay? That button is what you will use to find inverses of larger matrices. So like if you type in matrix A, you go to your calculator, you edit matrix A, and then you know how we went to our the names part and took A times B, on our screen? Well, if you just, on the names part, do A, and then hit that x to the negative 1 key, it'll take A and raise it to the negative 1 power, so it'll look kind of like this on your calculator screen. Press enter, it'll give you the inverse matrix of whatever you had typed in, and then you just write it out, yeah.
Wait, what?
Okay? So, I don't have a square matrix in there, I guess, right now, so take a little bit of time.
Oh, that's probably why.
Yeah, you need to have a square matrix. So if I
So like that, I think I did it.
edit, I'm just going to do a 2 by 2, or
Is
I'll
it gonna give
prove.
you decimal?
What was the one we just did in class? 3 what?
3, 4, 2, 1.
Oh, wait, what's a square matrix again? Like, what makes it a square matrix?
Same number of rows as columns.
Oh,
So if I go second matrix A, and then I press the inverse key,
it has to be square matrix for us to do it by hand.
yep.
What?
And here's the cool thing too.
No, 2 by
It'll change it to fractions for you too, just like it does anything else.
What? It's by hand.
Okay?
And then.
But you will have to show your work and do this by hand as well on your quiz next week. Okay? You will have to do this, and you won't have a graphing calculator
Does
to
that have
do
to
it
be
for
square to
you.
do an inverse too, or
Okay?
just by
It
hand?
has to be a square matrix in order to do an inverse. Yes. Yep.